Hey guys, welcome to the NC Barn Door Build channel. In today's video, we're gonna go over how to hook up this Nest thermostat with this MrCool 18K VersaPro unit and wire in this Santa Fe whole home dehumidifier. Along with controlling the system, we're gonna look at how to get 240 volts to power the outdoor unit and how to get power from the outdoor unit to the indoor air handler. Let's take a look at where the power comes into the outdoor unit first, and then we'll move to the indoor air handler. Your power requirements are going to be listed right on your outdoor unit, and you can see maximum fuse and minimum circuit ampacity. Those are the two important numbers for you. 30 amps is the max fuse. I have a 30 amp breaker on this unit, and by the NEC, if I have a 30 amp circuit, I'm going to use number 10 cabling. So I have a 10-2 wire, and we'll show you that here in a minute. Minimum circuit ampacity is 18 amps. So this thing can pull 18 amps at a time. And with 10-2 cable, we meet that requirement as well. Now, my 10-2 wire pokes out the wall here in the elbow up to my air disconnect. And that is basically this piece here. I'm either connected or flipping it out and disconnecting it, and that shuts power down to the entire unit. Now my 10-2 wire comes in here, and you can see I have this designated as a hot, and then my black here is coming up here. So my two inputs, and then the output is the red and the black here, and I of course have both my grounds. And we're going through this AC whip that you can buy at your local box stores, and it comes with the connections on the end. Comes in a nice flexible conduit, and you can hook it right up to your unit. Got mine at Lowe's, and you can see here that AC whip comes in here. I have two hots, a red and a black, and then I have my grounding wire. So we're hooking those in here. I had to put these connections here on the end. You can again buy that stuff all at your box store. And then I have my grounds hooked up, and then from this block I'm getting 240 volts coming out, number 1, number 2, and number 3. And these wires are all labeled 1, 2, 3. You'll see when we go inside, they're labeled 1, 2, 3. You just hook them up as they're labeled, and that goes in this black DIY Pro cable that came with my unit. It's number 14 wire, and it follows the line set up and goes right in the bottom side of my soffit over into the air handler. So this is pretty easy. The book is going to walk you through that, but that's how you get power from your main breaker panel to your outdoor unit, and from the outdoor unit to your indoor air handler. Now let's go inside and look at the air handler hookups. We're going to go ahead and put this auxiliary heat module back in. I had to take it out to mount the unit on top of the stand. I was running screws through the side of the sheet metal on the unit, and I wanted to make sure there wasn't anything on the back side that I was going to hit. So we took that module back out. If you haven't seen the video, I did a previous video on how to install the heat modules. But basically that module has the mounting block for the DIY Pro cable, so you can power the brains and the blower motor from the outdoor unit to the indoor unit. That's the top block, and then the circuit breakers on there is what actually connects your power from your main breaker panel, your 30 amps from there, into power the heat strip. So we're going to hook all that back up. All right, so this is where we're at. We're coming into the unit here with the power from the outdoor unit. We have the ground hooked up, and then you can see here 1, 2, and 3. And these cables are listed 2, 3, and 1 there. So we're gonna hook those up into this block here, and that'll be power for the air handler. And then our ground and our two lines coming in for the power for the auxiliary heat will be hooked in here. And then that's our breaker for it. And then we have all of our dip switch settings here that we need to adjust. We have our thermostat, 24 volt thermostat hookups here. And that should just about do us enough where we could get the unit turned on after we get our line set hooked into our 2 places there, get our drains hooked up for the condensate, and we should be in pretty good shape. So let's get this finished up and I'll give you a look at the finished product. Full disclosure here, this wire connection should probably be switched on the inside as well. I don't have line of sight to the external disconnect from the outdoor unit to the indoor air handler. Probably should have a switch here, but I don't. Now that we got the power run to the blower and the circuit board there, we can run the power for the auxiliary heat strip. And this comes from the main breaker panel. It is a 30 amp 240 volt circuit, and we're running this in 10-2 Romex. And you're going to see here in a minute, probably going to make people squirm a little bit. I put it in conduit. It is allowed by code as I read code. You can put Romex in conduit in dry locations if you properly size your conduit not to exceed the fill calculations allowed by code, and you leave that outer jacket on. So don't strip the outer jacket off and then stuff it into your conduit. That's not kosher. Shouldn't do that. I have a 1-inch knockout here. I ran the calculator. There's some online calculators that you can run to figure out your conduit fill percentages and your jam percentages. And what I seen, you could run 10-2 in a 3/4 inch conduit. I just don't have a knockout for it, so I'm using 1-inch conduit. This blue stuff I bought from Home Depot. It was cheap and easy to install and cut. It's just a plastic flexible deal, and once you get it ran, then you can go ahead and take that outer jacket off, expose your conductors, and then you can hook it in to your grounding screw there and hook the black and white into the circuit breaker that is on the auxiliary heat module. Pretty easy stuff, and the book it'll lead you right on through all this stuff. So you have the book, and then you have the schematics that will come with the auxiliary heat module, and it'll show you exactly how to hook all this stuff up. So this is pretty easy. The book, the instructions and the pictures, schematics lead you right through this. So we're going to hook this up, and then that'll be it for the auxiliary heat. We're done with that little module. All right, that's the power from the main breaker panel to power the auxiliary heat. So we're running it in some conduit here around. This is a 3/4 inch for 3/4 inch conduit, a knockout. This is for 1-inch conduit. That's a 1 1/4 inch knockout, I believe, or actually 1 3/8 for 1-inch conduit. And then this one is a little bit bigger. I guess if you had like a double, if they had the really big aux heat where you had to run a couple of cables through, or a bigger cable, you could use this bottom knockout. So you got a 3/4 inch, a 1-inch, and this might be like 1 1/4, I think, a knockout there. So you got 3 different options for conduit to run to your unit. And then what we're going to do next, we have our thermostat wire here. This is a 24 volt system. And I'm actually going to drill just a little tiny hole here, put a wire grommet in there and punch it on through, because it's going to get hooked in right here on the main brains of the system. So let's get that done next. You're going to see me struggle here with this hole. My bit was very dull, so I had to drill several pilot holes to get the 3/8 inch bit through there. I believe it's a 1/4 inch wire grommet that I ended up putting in there, and it required a 3/8 inch hole, and my drill bit just needs to be sharpened. But anyways, when you're drilling this stuff, it's not going to tell you in the book where to put your hole, how to drill it, how to do any of this stuff. So you just have to pick a spot. Don't damage anything on the inside as you drill your hole. Just be careful and get your thermostat wire through there. So there you go, thermostat coming out of the through pass down into the air handler. I put a little wire grommet on there for the hole so we don't get any chafing, and that's going to work out good because we can bring these right up and connect them into our circuit board there, and we should be in good shape. So let's get those going. Now we're into the manual here as far as specific wiring methods. So chapter 8.5, and it goes through your different options. You have 3 different configurations, A, B, and C. If you're going to use the wired controller that comes with the unit, these top 2 would apply to you. And this bottom one, if you're going to use a 24 volt system or a third-party thermostat, which we're using the Nest 4th generation thermostat, this will be our configuration. And then you have some options that you can put on. So you have condensate overflow switch, which we're gonna do later. We don't have any of the condensate plumbing in yet. We have an alarm that we can hook up. Going to the next page, a humidifier control. So if you have a separate humidification system for your winter time, I'm gonna try to get by without that for now, but that option is there. Dehumidification control wiring. This is very similar if you want your humidistat to control your air handler, your VersaPro, and run it kind of like a mini split where you run it in dry mode. That's what this is. We're not going to do that because we have the whole home dehumidifier, and that's going to do a much better job than the humidity control function on this unit. So we're going to omit that. The UV fresh air ion generator wiring, we are going to do that. We have an ERV that we're going to hook in for fresh air that hooks in with the fan work port, so we will look at that later. And then you have your control logic. So all of the labels here on the circuit board. What the manual doesn't do is really get into exactly what those specific things do. LED display, an overview of your circuit board. We get into the dip switch settings, which we'll look at a few of those, and the charts for that. Control scenarios. So control scenario 1, 2, and 3, and then based on that, you can set up your dip switches based on your control scenario. And then you have your air volume tables, which we're not going to get into testing that, but I'm going to have a guy come in later and we'll test out the CFMs and see how we're doing with our ductwork and getting everything plumbed in, power specs, and that's about it. So before we get too deep into the dip switch settings, I want to make this note. The manual is set up for a bunch of different units. So what I'm doing is I'm using the placards that came with my unit to set some of the dip switches, and I'll show you that now, and then we'll get into the book and adjust some of the blower settings that I think will be applicable to this specific setup. So let's take a look. The manual shows SW1 for a 24 volt thermostat to be set up with all 4 of the switches to the off position. My unit says I can do that as well. I can put them all 4 off here and let the unit decide that it's a 24 volt system, or I can go ahead and adjust the switch to put SW11 in the on position and the other 3 off. And that switch located here at the bottom, you can kind of see what I've done. I've flipped the number 1 to on, 2, 3, and 4 is off. Now I have switch 2, switch 3, and switch 4 here, so let's take a look at those settings. All right, SW11 we have set according to our specific model for a 24 volt system. The second switch on that is the cold blow protection. We're going to keep that on. It's defaulted on to yes in the off position. The single cooling or heating and cooling control, since this unit is doing both cooling and heating, we're going to leave the default alone on that. And then we go into SW21, that's control scenario 1, which is me. Compressor running, demand working with heat pump and electric heat. I want the compressor to run faster. That is the default setting, so we're going to leave that alone. I'm not going to use SW24. So you got 2.1, which is control scenario 2, 2.2, and 2.3. Those are 2s, which doesn't apply to me. Again, just going back, figure out what your control scenario is. That's if you're using the wired controller. And S1 and S2, that's control scenario 2. That's not me. I'm 24 volt thermostat, S1 and S2. The full, my understanding with the full 24 is if you're running 24 volt power out to the outdoor unit and controlling that with thermostatic wire as well. That would be your scenario. That's not us. So we're scenario 1. So coming back to this table, does not apply, does not apply, does not apply. The compressor here, this is just using the outdoor air temperature to control the compressor and the auxiliary heat strip. I'm not going to enable that because I don't ever want to shut the compressor off. And maybe if you're an HVAC tech, you can tell me why this setting may be important, but we're not going to use that. Over on the next page, we're looking at the 4th switch, SW24, that's control scenario 2, does not apply. Rotary switch, set outdoor temperature limitation for the auxiliary heating compressor, table A. I'm leaving that off. I'm gonna let the thermostat completely control the compressor and the auxiliary heat. SW31, maximum continuous runtime allowed before system automatically stages up capacity to satisfy the set point. This adds 1 to 5 degrees Fahrenheit to the user set point to increase capacity and satisfy the user set point. I'm leaving the default in here because it's more energy efficient to 90 minutes before it ramps up. And then we got cooling and heating, Y and Y2 temperature differential adjustment, faster compressor. Then we're going to keep that set. That's the default. Compressor running, demand working with heat plus the electric heat pump with electric heat. We're going to run faster compressor there as well to get the max out of it. SW33 does not apply, control scenario 2. We are going to change this one. SW34, that is fan speed of cooling mode when the 24 volt thermostat is applied for. You have 2 options, high and turbo. And if you go to the back page here, you can see cooling turbo, setting the switch 3, 4 to the on position. My CFM is going to bump up from 576 to 618. So that's going to get me a little more airflow. And with my house and the number of registers, I'm going to set that to on to let the fan run a little bit faster and give me a little more CFM. So again, that is SW34. Let's go ahead and turn that on. 1, 2, 3. The 4th switch, 1, 2, 3, 4. It's going to be this one. We have that switched on. Also, by the way, you want your power off when you're moving these dip switches, so completely power the unit down. So we're all set there with those, and then we have our last SW4 switch with 1, 2, 3, and 4 here, and this is based on your auxiliary heat model. So let's come back down here and look at this. SW4, control scenario 1, electric heat, CFM adjustment. So for me, we're gonna go back to this table. Electric heat kit 3 is what I have, the 5 kilowatt. So SW41 set to off, SW4, 2, and 3 set to on. It's going to use the W1, 2, and AUX terminals, which we have the AUX hooked up, and that's going to put my blower at 565 CFM. So just as a comparison, it'd be similar to the high mode in cold. 565 is actually the heat, and that is heat pump turbo in the heat mode. So it puts a little more CFM out in the cold mode than it does in the heat mode. So let's go ahead and look at those switches. So SW 1, 2, 3. So I have 1 off and 2 and 3 set to on. Okay, before I show you the wiring on this, a couple of things I want to explain. These MrCool VersaPro units, there's multiple configurations. You can actually have this air handler set up with an outdoor unit and a mini split head. You can have a dual fuel set up. There's a bunch of different ways to do this. And actually the book, if you look at the book, it is an 18K through 30K model. You can have auxiliary heat, which we do. You can not have auxiliary heat. There's a bunch of different options with this, and we're not done configuring it yet. But we have a pretty good start, and I have the system up and operational. One thing to note with heating and cooling, I'll demystify some of this for you guys maybe. This is a heat pump that heats and cools. So we're using this to do both. It has a reversing valve that flips the refrigerant inside the lines based on what you want to do, either heat or cool. So that is very important when it comes to wiring the thermostat. In gas forced air systems, typically it's going to be a dual fuel system in that you're using gas, you're burning gas to create the heat, and you're using a heat pump for the cooling. In that scenario, you're going to have two transformers. You're going to have a heating transformer and a cooling transformer. In this scenario, you have one transformer because two's not needed. You have the switching valve or the reversing valve to do the switching for you. So in that case, if you look at your thermostat wiring, you're going to have a Y1 and a Y2. If you have a two-stage unit, which I do, and the reversing valve is going to use that same Y1, Y2 for both heating and cooling, depending on the position that the valve is in. So with that being said, this is a single transformer unit. You have one 24-volt power supply that's running to the thermostat to power that. Without power to this unit, you don't have power to the thermostat, kind of, because the Nest has a backup battery that will power the thermostat for a little while once you lose power to this unit. But for the most part, the thermostat gets its power from here, and the dehumidifier that I have hooked into this has a plug. It plugs into an outlet. It's getting its power from that. So all I need for the dehumidifier is a signal, right? The thermostat to be able to say, hey, turn on or turn off based on the relative humidity in the house. We'll get into that wiring later. But let's look at this wiring now that I kind of gave you an overview and hopefully helped you think about how your setup's going to be. With the unit off, you're going to see double zeros here. So I do have power to this unit, so I'm going to be very careful on what I touch here. At the top of the 24-volt bar, you have the orange. At the bottom is the red. So let's just kind of talk about these. The red is the R mode, that's the power. So I'm getting power to the thermostat via the red wire. Blue is common. The C wire, that is basically the neutral wire to complete the circuit. Green is for the fan control. Yellow is Y1 for your first stage heating or cooling, depending on where the reversing valve is. Brown is stage 2 heating and cooling, again, depending on where the reversing valve is. Black is the reversing valve control itself. The VersaPros are set up to be a B control. So when you set your Nest thermostat up, make sure you select in the configuration B for the reversing valve, because it's going to have one hookup, O and B. And then this top orange line you may have or may not, that is the aux heat, which is run from here. Again, we ran power from the breaker box, 30 amps into this. This is a 5K unit. So we have our 240 volts. We have both of those are hot. I need to actually mark this as hot and put a little black with my marker on that. We have the ground here. This is the signal and power lines from the outdoor unit. So this indoor unit gets power from the outdoor unit. So we have power there, and then we have the signal line, which is the yellow running across there. So 1, 2, and 3. So line 1, line 2, and 3, which is the signal. And then we've already talked about the dip switches we have set. We have the 24-volt bar turned on. And I'm not using any of this. We talked about that briefly. I'm not using any of the outside air temperature stuff. I'm letting my thermostat do all the work. So I've disabled that here. There's a couple of different things you can do with the MrCool, and you can choose to either do it with the unit here and the brains here, or you can use your thermostat. I'm using the thermostat to do it. So that's the wiring here. So that is 7 wires. I ran an 18/8 thermostat wire, and you can see my white wire there is being unused at this point. So let's go ahead and look at the Nest, and we'll show you how that's all wired up. Right, so here's my Nest thermostat. We're gonna go ahead and pop this off the wall. Take a look at the wiring here. So you're gonna notice, I don't know, you may be able to see this, you may not. These are labeled a little bit different. And again, you have to remember this Nest thermostat is compatible with a bunch of different systems. So you may or may not use all of these different hookups. So let's just kind of go through this. So Y1, Y2, we've talked about. Stage 1, heating and cooling. Stage 2, heating and cooling, depending on the reversing valve. G is for the fan control. OB is the reversing valve. And again, two different configurations here. You can have it set up for O or B configuration. The VersaPro, it says in the manual that it is a B unit. So we have selected B configuration. As far as power to the thermostat, since we're a single transformer, you can either hook it into RC or RH. The thermostat will know if you only have it hooked into one or the other that it's a single transformer. So we have elected to use RC, so it knows, hey, we're a single transformer, both heating and cooling, and is going to get its power from here. And no jumper wire is needed because it does it internally into the thermostat. Orange, if you remember, W2/AUX, that's our auxiliary heat. And again, we're going to let the thermostat control when it needs to use auxiliary heat. You can set up the MrCool VersaPro to do that as well, based on your S3 switch setting, but we're gonna let the thermostat do it. I think it's a little better setup there. C is the common, again, your neutral. And we actually have this neutral wire pigtailed behind here because the dehumidifier needs a neutral or return wire to complete the circuit as well. So the air handler and dehumidifier are pigtailed here. And then I ran that one line into the C. And then we have our star here, which is the control for the dehumidifier. You can configure this hookup for different pieces of equipment. Mine is the Santa Fe 70. So we have that wire hooked in there to control that piece of equipment as well. And that's the gist of the wiring. So we have 8 wires in here and 7 hooked up into the air handler. And we have 2 hooked up to the dehumidifier. So let's go back and look at the dehu. For me, I ran 2 thermostat wires out. I had to buy a spool of the 18/8, 250 feet. So I just ran 2 strands of this, not knowing exactly what I was gonna need. And I'm gonna run the second strand behind the air handler and hook it in to the dehumidifier. And basically on this, it's pretty easy to set up. I have the dehu, the red wire into the dehu control, and then I have the blue into the common. You have other options. You can hook other equipment in here. You also have a 24-volt transformer in here too, so you can power accessory equipment off of your dehumidifier if you need to. But that's the wiring there. So just 2 coming off this, going right back to the thermostat, which allows the thermostat to control this. Once the humidity drops below whatever your set point is, I have mine set at 50%, it'll kick this thing on. We're up to testing the unit now. We have everything hooked up and I'm in the cooling mode on the Nest thermostat, so let's see how it's working. So you can see we have our set point set at 67, it's 74 inside, 70% relative humidity, 77 outside. And after a couple of minutes, we're starting to get water out of the drain pan, which is a good deal. I just have it draining into a bucket for now for testing. You can see how quiet this unit is. That's stage 2 cooling. Really not bad. So I'm gonna call that a good test. We just obviously need to get our condensate drain hooked up. We'll do that in another video. But yeah, we're looking good there. I'm gonna go ahead and shut this off. All right, we're gonna go to the off mode. Off, there we go. Well, that's about it for this unit. We're gonna run it in heat mode. Not really much to show you guys with heat mode, but the cool mode seems to be working really well. Lots of condensate, which tells me the coils are getting really cold in there and bringing that humidity down in the house. We also have the dehumidifier hooked up and it tripped on. I don't have a drain pan for that, so I didn't want to leave that run too long, but that seems to be working as well. And so far we're looking good. We got an ERV yet to plumb into this thing. We got the condensate drains yet to do, obviously, and the duct work for the return side. but otherwise we're looking pretty good. That'll all be on the next video as we finish this part of the project up. I hope you'll join us. That's all I have for you guys today. We'll see you on the next video.